everyone. How are you?
Good.
Good.
How are you?
I'm great. Thank you. Welcome to all on this already Friday, which is really nice. To the students in the room, you know how I feel about you. I'm always privileged to share space and time with you. To our guests, thank you very much for coming. This speaker series is sponsored by the Data Institute, which is the umbrella organization for all data science and data engineering programming that happens here at the university. And today we're really excited because one of our favorite faculty in our Master of Science and Data Science program, Yannet, Interian, is here to talk to us today. Yannet has a PhD in applied math from Cornell University. And today she's going to guide us through natural language processing and its real-world applications using Hugging Face, a leading platform for AI-powered language models. So without further ado, I'll hand it over to you.
Hi guys, I'm really excited to be here, to see you again. I don't know, I forget how much I miss you. Well, and I see a few of you on video, but not all of you. So I wanted to start by saying that, so I have these tutorials, deep learning tutorials. Today I'm mostly gonna go through number 2, which is an intro to Hugging Face API. But if you guys have any other, so for example, the first one is about image classification. The second one is the one we're talking about right now. The third one is about fine-tuning LLMs. And the fourth one is about image segmentation. And in general, I think I told you before, but I want to say again, if you have a problem on your practicum or in general in machine learning and you want to chat about that, sometimes I'm not around, but I am on Zoom. Okay, so I'm also around the whole next week, so also come and chat if you want to. I'm happy to chat about your practical problems, all of it. Mm-hmm. So anyway, so what I want to talk today about is so how to use Hugging Face, which is a platform that has a lot of different models and tools are free to do different things in machine learning. So as I was saying, so Hugging Face, probably you guys already know about that. It has a lot of NLP tools, libraries, pre-trained models, and so on. And things are getting a lot more interesting right now since like the newest DeepSeek is also in Hugging Face. The only problem is that you need to have a little bit of a big GPU to actually get it to work. But if you do have that, then you can have access to that for free. And then we have the Transformer library, which is the Hugging Face most popular offering, has a collection of pre-trained models and to do a bunch of different NLP tasks. These are mostly based on the Transformer architecture. These are models like BERT, GPT, and others are all based on that architecture. So the first task I want to talk about is basically whether a review, for example, a review would be positive or negative. So for example, this one is a movie review, and I have highlighted in blue a few phrases that tell us, how we might feel about this review. So for example, it says a good story, a story unfolds flawlessly, acting is without faults, occasionally quite brilliant, warm movie, blah, blah, blah. So kind of it's clear that this is a kind of a positive review, right? So it used to be some years ago that to be able to do something like this, to be able to have a model that will tell you whether this review is positive or negative, you're going to have a large data set and you're going to have to train a model to tell you if it is positive or negative. What happens right now is that there are a bunch of models that will do that without any training right now. And that's what I wanted to talk to you about. So the first task is just whether some text is positive, negative. Sometimes they also add neutral to it. And basically, so I just wanted to show you how you would do this in Hugging Face. So there is something called a pipeline, which makes everything very, very simple. And it's kind of the best way to enter and play with Hugging Face. So what you do is to say, well, pipeline, I would like to be able to do the sentiment analysis task. And so you just say pipeline sentiment analysis. And then you have your data. Your data is on a list of text, right? It could be just very simple as these 2 sentences, or it could be a lot larger, right? And then you just take your pipeline, this pipeline through your data, and you get something like this. Label, in this case, the first one is positive, and the second one is negative. So we're all good, we understand that. So can we do this on any data? Just kind of any data. So what I have done on this notebook that I told you about is that I took a data set from Stanford that has also this binary sentiment classification task, in which basically what they do more or less is that they take a bunch of different reviews of movies, and if the review is above a certain threshold, like maybe 4 or 5, they call it positive, and if it's below, they call it negative, something like that. They do a binary task, and they have a bunch of data. So these are like 25,000 movie reviews for training, and 25,000 for testing. So and then what I do here is just to show you is that I have read all of these reviews, and I have some of them in the positive and some in the negative. Okay, so I have divided the positive and negative in different places, right? And I'm just gonna go and see what happened with the first 10 positive reviews and the first 10 negative reviews. Okay, so I go there and I apply my pipeline to that, and I get, in the case of the positive reviews, I get all of them are positive. Okay, in the case of negative reviews, notice that one of them says positive. And notice how all of these deep learning models, they are always very sure of what they're talking about, which you have to be very afraid of. But don't these scores sometimes make no sense, but because it's always like super sure. So in this case, actually, I think the model is right and the data is wrong. Right? So I'm going to show you. So if you read this review, I should have highlighted some parts of it. But let me say for you, well, you can go and read this review, and I should have highlighted the best part, but just even look at the last sentence. Good fun stuff. So if you read the review is positive. It's not negative. So somehow the way the data was collected and the way the person that wrote the review probably gave it a number that was like 3 or whatever, but then the actual text is positive. So in some sense, like the model is better than the data in this case. So anyways, in ordinary case, for sure it's gonna happen, but in my experience, every time I see something like this, the model is right and the data is wrong. So basically, okay, so let's keep talking about pipelines, okay? So every task for this pipeline has a default model attached to it. And it's supposed to be a good model for that task. But it doesn't mean that you cannot play with different models. So for example, here I am specifying the model that I want to use, sentiment, Roberta, large, English. It sounds like a sentiment model to me, so I am going to try that. And I just have to give, basically, I just have to specify the model. The model always has some kind of it kind of looks like that, and you just have to get it from the pipeline, from the website at Hugging Face. So anyway, so you can use different models. So how do you figure out the models? Okay, so what you do is that you go to Hugging Face, and in this case, we are looking at sentiment analysis models, and you have a bunch of them there. Which one is better? Well, you have to try different things, see what happens to your own data, and you have to look and see how they were trained. A lot of them, they are also, depending on the task, some task guys like this one is pretty simple. So like a small model would be fine, fine-tuned sentiment data would be fine. If you have a task that is more sophisticated, you might need a beefier model, some model that is more complicated, right? Another thing that you want to consider is how long is your text? Because a lot of these models have a maximum input you can give them, and many of them is like 512. But there are models that will take a lot more, double or more. So depending on how big is your text, you might want to figure out what to do with it. You can also do things like, say, divide your text in pieces, get a prediction for each piece, and then maybe average or something like that, right? So there are many things you could do. You just have to be aware that the text, yeah, you have a question?
Yeah, Yannet, for your example earlier, for the sentiment and the pipeline command, does, like you said about something about like a base model it uses.
Yeah.
Does it come with the installation of the API?
Yeah. So when you try to run this pipeline, it will download the model that you are using to your machine. And by default, every task has its own model, like a default model. And we download the model for you. Yeah.
Which one is the default? Like, it doesn't show you which one?
When you are downloading it, it will show you the default. It will tell you, hey, I'm downloading blah, 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 blah. And you can also go in the documentation and figure out which one is the default as well. Yeah. And basically, if you look at the documentation, they say, oh, this is the best model for the task. But, who knows? It might not be the best model for your data. So you might want to try to, or for example, there are multilingual models, there are models just trained in English. So it depends exactly how your data looks like, right? So you have to like try to see which one is the right for you, the right one for you. Yeah. But yeah, so basically you go here and you see that they all have like a bunch of love and a bunch of downloads. So hopefully that correlates to something as well. So you just like try maybe the most popular ones and see. But also, to be honest, it also depends on the resources you have. So these models are gonna run also on your CPU, no problem. I was trying to use the biggest JAMA models, and they don't fit on my GPU. So that was quite sad. I was crying for a while. So anyway, so I had to downgrade to 1 million parameters. So anyway, so it depends what. I think I can fit 2 million too. I have to try. Yeah. So so if you actually want to try JAMA, you have to or Llama. I don't know how it's in Spanish. It's JAMA. So and that's the Spanish word. So if you want to try that, you have to ask. You have to ask for access, and they, I got it. So I don't know why you wouldn't get it. Right? So yeah, so it's fun to try that. Okay, so you have your task and so on. So what is going on inside of that pipeline? You can actually write more code than that. The pipeline is just a simplification, right? But you can actually go and write a lot more code. Once you maybe want something more sophisticated, you might want to write all of that yourself, and you can find how to do it. It's just that right now they have done it so easily that you use this pipeline that maybe you don't actually need to, right? But basically what there is every model also has a tokenizer. Remember, because those models are trained in a particular way, and so each one of them will have its own tokenizer. And so it will take the text, tokenize it. It will have this default model that comes with the task, right? And then you will get kind of the outputs, right? And if you remember, I think we talked about this before, but how we tokenize is we take some text and we divide the text in pieces that we call tokens. Sometimes the tokens are not really words, they are sub-words, right, as well. And so every model will decide that. So every model have a different way of tokenizing things. So you have to use tokenizer for that particular model you're using. And then that will get returned into, you remember, into numbers, into IDs for every token. And also, like at the time when you predict, you will predict kind of probabilities on tokens, right? And then there will be a way to decode that back into words, right? And the decoding algorithm is kind of quite interesting. There are different ways to do it, and it's out of the scope of this talk. So what other tasks are available? Actually, guys, I looked this up yesterday. Some of them, I don't know what they are, but they look quite interesting to me. So, audio classification, automatic speech recognition, depth estimation, that's probably for images. Document question answering, that's actually quite, that one, I think the document is an image. Feature extraction, anyways, image classification. So a bunch of things about images, feature extraction, image segmentation. Yeah, so all of that, mask generation, object detection, question answering, summarization, table question, anyway, so it goes on and on and on. I think these are all of them, the ones that they have right now, but I find them quite interesting. For example, I actually wanted to try this zero shot classification because there is this one that is classification and it's zero shot, so I don't understand the difference. So anyways, I'll have to dig more into that. But anyways, if you guys have a problem and you don't have that much data, or even if you have data, I think you should start with these models and see how well they do on your task, right? So basically, the next task I want to talk about is text summarization. And there is a little bit of a difference between a model that just has classification, that has to say 1 or 0, right, positive or negative, to a model that is actually generating text, right? So a model that generates a summarization, in general, has to be a little bit of a better model, right? A very tiny model can do positive, negative, like no problem. But you have to generate text, it has to be a little bit of a better model. The good thing is that the models, these models are not that big, and they do quite decently, I think. So this is a data set in which basically we have news. I'm going to show you how it looks like, actually. So they look kind of like this. Ever notice how things appear to be getting smaller and smaller, blah, blah, blah? So we're going to see what we summarize this in a while, in a little bit. So anyway, so we want to do summarization. We're going to use this model called T5 base. There are many different types of T5 models, and they are all quite good. And they are not very big. So they are little models from Google, and they are good. They do different stuff. They're fine-tuned in different ways, so you can figure it out. And USF, don't do that now. Okay, start 4 hours. Okay, so basically, like what we have here, the top is a human summary, and the bottom is a model summary. If you read, the summary reads very well. I mean, I don't know why it doesn't go capitalized and stuff like that. But if you read the whole thing, it sounds pretty good. That summary. And it's a bit different than the summary that a human is doing, but it says similar things. So what else we want to talk about here? So when you're summarizing, you want to give a max length and a minimum length as well. So because you want to control how big your summary should be. And I don't know if you have noticed with ChatGPT, they like to talk, right? So you have to give them constraints a little bit sometimes to tell them, I want you to be concise. I don't know if you have tried that. It works. Or check grammar. Don't try to rewrite my right. So you have to. Your prompts have to be specific. Otherwise, it goes like oh, whatever. So the same here. You have to constrain how big you want this summary to be, because it's easier to make a bigger summary, right, than to make a smaller summary. The number of beams controls also the quality. So if the beams are larger, this has to do with the decoding or finding the best summary. If the number of beams is larger, it's going to take a bit more time, but maybe the summary is better. And these are, there are some other, you can basically, it's good to figure out the different inputs you could give for this particular task. The next thing I want to talk about is something called zero-shot classification. The word like zero-shot, what it means is that, so you have a model, and you're asking this model to classify, say, text into some categories. But that model hasn't really seen these categories before, explicitly. It hasn't been trained to classify these categories. But you can still magically ask them to tell you which category is the best one. Does it make sense? So I'm going to show you, the first time I saw this, I thought it was pretty cool. Now I think it's just large language models. They do a lot of stuff. But the first time I saw it a couple of years ago, I thought it was pretty good. And this is very useful if you have a lot of data, you are in this practicum, they want you to do this like crazy stuff. You don't have somebody to label your data. Well, maybe this is not perfect, but it might be a good start, So I'll tell you why it's not perfect. So let me, so this is a data set that I found somewhere on the internet. And so we have some, this is some news, okay? So they got the link, the headline, the category, and some short description. So it's not the whole article, but a short description of the article, okay? And what I'm gonna try to do is I'm gonna try to ask the model to predict this category here. And what the model is gonna do is gonna use the actual word I'm giving, the label as a word, and it's gonna try to figure out how to match the short description in the best way possible to the word of the label. Does that make sense? It's pretty cool, no? And of course, it's not gonna be easy in some ways, because what's the difference between US news and, there's another one, it's called world news. How do you put something into US news or world news, right? I'm going to show you this one that is sort of comedy. I'm going to show you that the model gets it wrong, but you're going to see why, because you're going to see why. So basically what I'm going to do, I am going to feed a bunch of these. I'm going to tell the model, hey, use these categories. So I'm going to provide the categories, and I'm going to say, hey, given these categories, give me a score for each category. So because the models usually, if you have categories, they will give you probabilities or scores. So in the same case, give me scores for these categories. And then you will usually use the maximum score as a predictor, right? In this case, yeah. So this is how I do it, right? So I have this data frame and my short description. I'm gonna use this. You go around and ask, what's the best model for this particular thing you want to do? And, people told you, or the internet tells you what is an okay model for it, so that's what you're using. So in this case, I'm using this BART large MNLI, which is a data set that is very famous. So you say, hey, I have this pipeline, I'm going to give you this text, and then I am going to give you these candidate labels. So I decided to put everything in lowercase. I don't know why, but I'm telling them, to classify this into these labels. And then for one of these, this is what I get. US news 0.5, world news 0.3, which makes sense because again, what is the difference between world news, US news? It depends. Even it depends, like, well, if you're in the US, it's more clear, but I don't know. Like, it's not even that clear that short description might have even the information if this is in the US or in a different country. I don't know, right? So anyway, so that's what you get, right? In this case, I just gave these. I think in the next one, I'm also going to add tech to it. So let's see what happens in this case. So I give it to a bunch of different. So in this case, I use labels: U.S. news, comedy, parenting, world news, tech, and you see the actual versus the predicted. So a lot of them are okay, and some of them are not that okay. For example, this one, the actual is US news, but the predictor is tech. But I'm sure if you go inside that, there is something about tech there. And then you're like, okay, you know how, yeah. So actually I didn't go into that one, I went into the comedy one. So there is one that the actual is comedy, and the predictor is parenting, and I'm gonna show you what happened there. So anyways, it's not perfect, you see? So this one is also tech instead of world news. This one from culture and arts to comedy, like, okay, we will have to look into that, but I didn't go. But it's actually interesting that it gives you something, If your categories overlap, you're gonna have a problem, right? But if your categories are far away, I think you might actually get pretty good accuracy, right? So in this case, I think the overlap and the fact that you have a short description, if you actually had the whole article, it also might have been a bit better, right? So what do you think about this? So the model I think is parenting, but the actual was comedy, right? So basically my conclusion is that the model doesn't have a sense of humor, but but anyways, right? Like, I mean, from the model point of view, we're talking about toddler and about, I don't know, grown-ups, whatever. It sounds that the model has a point, right? So okay, we keep going. So anyway, so this is kind of useful, right, guys? I think. No, I thought it was an interesting.
In this case, are the candidate labels being passed as part of the prompt,
or? In here, the prompt is all inside the. This is what is good about the pipeline is that you are just giving this, giving that. These models have been fine-tuned to be able to do that, and probably through prompt or instruction training or something like that. And I actually don't know that much. I should actually have looked more into it. But yeah, I don't know if it is effectively the prompt, but they also train a little bit to do this. Yeah.
So when you're getting those candidate labels, did you have to fine-tune the model head, and the Facebook model is outputting embeddings, or this model is directly doing those candidate labels?
This model is directly doing those candidate labels, yeah. That's what I am asking it to do. Probably there is something inside the way all of this work, like the code, that does something for us, right? That I haven't read, so we should maybe read it, But this is exactly how I'm using it. Yeah.
Can you exchange candidate labels with any arbitrary?
Anything. You can. I just put that randomly. Looked at how they are like in lowercase and the other one is in uppercase. You can put anything in there, and it will just do the scoring the best it can. So in a way, think about it this way. What the model is more or less doing is this. Take the, more or less, I'm imagining, right, that what the model is doing is this. Take the text, embed the text in give an embedding of the text. Give an embedding of each label, and look at distances. It's more or less that. I mean, it has to be that. And yeah, it has to be that. You know what I mean? So basically, I think that's what it's doing. So you first embed the labels, get these embeddings, right? And then you embed the text. And then you see in some way, in some distance way, which one is close. That's what I think it's doing. Yeah.
So what's the advantage of this over, like, let's say making a call to a large language model prompt to get
Free. It depends on how big your model is. I mean, ChatGPT is a very powerful model, so it would be better, right, than this. But this is free. So if you work at a company and you have to do this all the time, then you might want to use like the free resource, right? Or if you're if you also don't, your problem is not that complicated. You don't want to spend a lot of money using I don't know, API with ChatGPT that costs you money, right? Yeah.
Sorry for so many questions.
No. People here have the same question, so don't worry. Yeah.
So would it be still cheaper than ChatGPT or OpenAI if you had to host this open source model on a server?
That is true. So I am assuming that I have free GPUs. So for me, it's pretty useful to know how to do this, right? So a lot of companies already have, you have some GPUs that you can use, you have your things that you can use. But it is true that you have to understand what is the cost benefit. But if you have already some GPUs and stuff that you can use, this is free. The other one costs you money. And these models, this one you're gonna see later that I have a comparison between different models. You can use big models. I mean, you can use DeepSeek if you have the infrastructure to run it, right? So you can get as good as ChatGPT in many ways by using Hugging Face. But yeah, you have to host it yourself. Yeah. So the next one I wanted to talk about. So I am doing a little project with a practicum, and we actually just got a new client. So we are doing a little chatbot for MSDS. So with citation at Turo here. And so one of the problems we are having is that we have a lot of websites, and we would like to extract questions and answers from websites, from different websites, for the application that we are trying to build. And this is complicated, right? So we have all of these texts, and we are trying to extract that, right? Of course, we're going to use a large language models to do that, and the question is, is how, right? And if we could do it for free, it's a lot better than not doing it for free. So one of the things that we're considering is using one of the Llama or Llama models, because they're already this task is a lot more complicated than anything else I showed you before. So people have been doing summarization for a while. It's a task that people have data for training on. Even if it is complicated, people have been trained on this for a while. But there are not that many data sets that are asking ChatGPT or any other model to extract questions and answers from a website. So one of the things we are experimenting with is using Llama. And I had to just ask for permission to use Llama 3.2. I didn't know at the time that it was 3.3 also, right? And I got permission overnight, so it's something that they give it here, right? And as I was telling you, I tried a little bit of a beefier model, like 8 billion parameters, and that just quite didn't work on my machine. But if you have a little bit, our GPUs here are a little bit old, so if you have a better GPU, it would actually work. So anyway, so our task is extracting questions and answers from text, and so that's weird. And I tried other models, and I think I have to still do a lot of experimentation with prompting, I think. And I'm going to show you one that works reasonably well for this task that I have, but it doesn't work that well for our data. So that's why I'm not showing you our data. I'm going to show you one that works, because that wouldn't be a good demo, right? But so we're still kind of working out the right, I think the right prompt actually to make it do what we want. or even sometimes we may have to do a series of steps to actually get what we want. We are still trying to figure that out. So anyway, so my first attempt at a llama is this one here. So there are a few more things here. So we are doing text generation. We are using this torch type, a float 16, to save memory. And the auto is, is for you to figure out what's the best way to do it. And then this is the first, I was chatting with ChatGPT, asking him to help me out. And I don't think ChatGPT, well, it's good. You have to keep talking to him, and maybe one day he will give you the right answer. But so he said, try this, and it works a little bit. So basically, so I was actually talking to ChatGPT saying, hey, is a multi-step process better than just one, just kind of one question to get this task done? And ChatGPT came up with this idea that we asked the model to first identify key facts on our text and then ask questions about these facts, right? And in certain cases, this prompt works better than just asking, can you give me questions and answers? But I think we still have to think more about prompting for now. So anyways, this is identify key facts in their answers, generate multiple questions and answer pairs. I actually had to add a little bit to this, and I forgot to add it here. I had to say something about within the text we have, because the text I'm giving is about Paris, and also the model came up with other questions that were not in my text. So I had to even say, hey, don't just kind of concentrate, right? So you have to play with that. So anyway, so these are some of the options you have: the max number of tokens and the temperature, sample equal true, and then we have our text. So let me tell you, it actually comes up with a bunch of different things, but yeah.
Can you go two slides back?
Yeah.
When you select the float 16, are you quantizing the model, or are you just selecting it to use less memory?
I don't think so. I think that there are models that are really quantized, I think, but we will have to look more. But I think what it's just doing here is, I know how to do this in PyTorch. Like in PyTorch, you just say, hey, I want you to do everything in, you can even train on float 16. So basically it's just saying instead of float 32, just train on float 16. And they have some, so you can train or do inference. In this case, it's the inference that we are doing, probably.
Okay.
But I don't think, I think there are other models that are quantized, and I don't know that much about it, so you have to look at it. That's a good question. So anyway, so the input that I'm giving is, so it's about the Eiffel Tower. So we tell that it's in Paris, that it has been completed in that year, and it stands, and how tall it is. And then, anyways, after tweaking a little bit the prompt, I actually got the questions and answers that I wanted, right? Now, the text that we have is not as clean, that is more complicated. Also, one of the things we have is that sometimes there is a question, and there is a section, and the question is not complete without the section title, right? So our model gets a little bit it tells us things that without looking at this. So I think we have to do a lot of pre-processing to get this to work better. Like, for example, we came up with this idea that, we have to add the kind of the title of the section, if it exists, to the question, because the question without that sometimes is not complete. And then the answer is very generic and it's wrong in general, you know what I mean? Without that. So So it's like, how long is a visa? Well, it depends which visa you're asking for. It's about immigration to Spain. You know, this is my favorite topic, right? So, so that's all I think about. So, so that T-shirt I wanted, the one that you guys designed. So anyway, so it's very complicated. Data is very complicated, and you have to look at your own data and come up with ideas on how to clean it and how to. So in this case, this example is simple, but then I think it will have to be worked out a lot more. In the same way that you will have to play with ChatGPT to prompt it the right way to give you what you want as well, right? So this is kind of similar. Yeah, but working on it. So let's talk about these models that we have been using, right? So at least I want to tell you a bit about them. How many parameters do they have? Notice that the llama model is the biggest one, right? And the other ones are a little bit bigger, a little bit smaller, right? So this is like some part of it. Another part of it is like how are they, and I have here a summary of how are they gonna be fine-tuned, or how. So the first model is Roberta Larging with sentiment. Has been fine-tuned. It's a checkpoint of Roberta Large, and then it has been. I think it's been fine-tuned on sentiment a little bit, but otherwise people think it's good for sentiment. It's called sentiment. So enabler binary sentiment analysis. So it's been fine-tuned a little bit for sentiment, and that's why people use it for sentiment. The T5 base, actually T5, this is the base, but there are specialized T5. I just didn't find a difference between the base and the more sophisticated one on this particular task, but there are more sophisticated T5 that have been fine-tuned a little more in different ways. And this one, so it's just a general model that is good for many different tasks. So that one is a good one. And then this one, the Facebook one, the very large MLMLI, so it's been fine-tuned on this data set that is, this is one of the data sets that people talk about when they talk about how good models are. So it's a data set that is very challenging, and people compare different models from the data set. So it's one of these like benchmarks that people are trying to get your model to be better than other models have. So it's been fine-tuned on that. And then this Llama Instruct is an instruction-tuned variant of Llama that is optimized to follow user instructions. Make it good for a task that requires specific guidance. And all of this like keeps evolving, right? So the Llama models, they keep making them better. So now they are on the 3.3 version that is available. So all of this is evolving, and it's basically about like how complicated is your task, how good are your resources, and just trying to see what works for your task and your data. So this is this is from the paper from DeepSeek, and I just wanted to point out that so there is DeepSeek, which is open source. There is Llama 3.1, a big one actually that I cannot really use on my computer, but and this is a comparison between them. And I just wanted to point out that there is a lot of free models out there that are pretty good. And maybe you really don't need the bigger one. A lot of the tasks that you're gonna do might be that smaller ones are fine. But if you actually need the bigger one, they are there too. So it's pretty cool. So the other thing I wanted to briefly mention is that you can also fine-tune a model to your own task. And I have there are different ways to fine-tuning too. And the one I have in the notebook is one way to fine-tune. There are many different ways to fine-tune, and you can read about that. But the good thing is that you can take one of these models, like I think I'm doing the Google one. I think I'm fine-tuning this one. The T5 base, I think. I can look it up. So you can take one of these models, take your task, and fine-tune your model a little bit. And then it becomes much better at your particular task. So suppose that if we want to build a chatbot for MSDS, which we are going to build, we don't need a very big model. We need a model that can generate text, for sure, because it's going to have to generate text. But it just has to know about MSDS, and that's it. The amount of questions that it is able to answer is maybe 100, right? So it could be a tiny model. I don't know what we are going to be able to do, but it's going to be a tiny model. You just have to be able to have good grammar, right? That's it, because otherwise it would be plain, right? One model has to have good grammar, right? Right. So, but basically, the other part of the thing is it has to be able to say, hey, I don't know about what you are telling me, but I can ask Aya about it. You know, right? It has to be able to say, I don't know about this topic, and I know about this topic you're telling me about, right? And it needs to be able to write a little bit, right? But it probably can be a very small model, right? For this particular application. And then also everything you do is cheaper, because remember, you're gonna have to host this. So you have to think about really what's the cheapest way to do this. Otherwise, MSDS cannot make them. So anyways, you might not need a big model really for the task. And the question is how to do the smallest model that is still really good at what it's doing, right? So anyways, we hope, we don't know which model, but we hope that it's tiny, the one that works. So anyway, so you can fine tune also the model to your specific task. The first thing though, as the person that did the last talk last week, which I read, is basically try to use prompt engineering first, right? But then, maybe a little bit of fine tuning might be what you do, and maybe it's even better because then you can have even the model to be smaller. I don't know, something that you have to experiment with. Okay, so I think this is what I have, and if you have any questions, I'll be happy to respond to some of them. So this is the link to these tutorials here, and otherwise, you have some question here, or yes, good, no, okay. Otherwise, I will,
Various browsers are free to use, and so naturally a browser came along, DuckDuckGo, that takes your question and puts it to different browsers and compiles the results. You showed a slide with different free models. Is it possible to do something like that?
You can combine models, right? Your application can be like a mixture of different models as well, in which you already kind of do that. I think actually like ChatGPT is a mixture of models actually, some models that maybe even specialize in different things, and then you combine them. But you combine them before, right? Before even, you do the whole study combining them, and then you come up with the best answer, hopefully. I think you don't want them giving the user 5 different answers, right? You want to combine them underneath, and then give you.
That's the piece I was wondering about.
Yeah, you will just combine them. I think that what I read, I don't know that well, is that a lot of these bigger models are combinations, are a mixture of models. Like DeepSeek, that's actually, I think, what they say. And apparently ChatGPT is probably a mixture of models too. And we don't know how ChatGPT is trained, but that's what the internet is saying. So it's different models and hopefully specialize on different things maybe, and they get combined. So for example, one thing that they were saying is that they can get models to be very good at coding, but those models are not the ones that are very good at something else. So you can specialize a model to do coding very well. And at the point that you are trying to figure out who should respond to this question, maybe there's a little classifier in some ways that says, oh, you respond to the question.
That's one way of doing it. The other is the scatter shot that I was thinking of, just putting out to everyone and then.
But that wouldn't be a good user experience, right? Because users want you to want one answer,
but
right?
combining those answers, but you're combining a good model's answer with a not so good model answer, so that's not so good a model.
Yeah. So this is being done, but I think more underneath, basically. I think, yeah. Okay, guys.
Yannet?
Yeah.
How does the Transformers library compare to like LangChain and other versions?
I think there are different tools, like I think LangChain is doing all the things, not exactly like this part. This actually gets combined, right? And I don't understand the whole piece completely, but they're doing different parts of it. Like I think I'm not sure what it is. I think it's they get combined for different tasks, say for RAG or for other things like that. I understand. Yeah. Okay, guys. Good to see you and see you around. And remember, we can chat on Zoom if you want.
Everybody, join me. Thank you.